Now this question is a bonding question. It's given us some data and asks us to show that we understand it with our basic understanding of chemistry. And we're looking at the boiling point and melting point of the noble gases, and we're given some information about a model to do with a sea of electrons and metals, and given some information about some metals over here with their melting point and boiling point. Now, the first question is to explain the trend and boiling points of group 18. So we don't need to discuss the metals at this point, just group 18. We'll have a look at some key things. First thing we notice as we go down, this is minus 249 to minus 112, so we're seeing an increase in melting point and boiling point. Also, the difference between melting and boiling point for each element isn't that significant. So what do we need to discuss? Now, the first thing obviously is we should make sure that we give as a complete answer as possible. So that's not taking anything for granted. Now I'll just go over that. Now, first thing we talk about is kind of fairly general stuff to do with boiling point and melting point. And in doing so, we talk about the strength of the bond, how if you have a high melting point and boiling point, it shows it's a strong bond. Therefore it takes more energy to break, and therefore it's going to have higher melting point and boiling point. So we've got to put more energy in to break those bonds. Now, the type of bonding that we actually have with these, as well as the polarity, is a good thing to talk about, because being noble gases, they're going to be non-polar, and the only kind of bonding they're going to have between other atoms is going to be temporary dipole type bonding, so there's kind of weak dispersion forces. And what that really means is, obviously, the bigger the molecule you get, so as we go down, the bigger the molecule you get, the stronger the bond is, the higher the boiling point and melting point, etc. So if you're linking all of those concepts together to show that you understand that trend and what it really means. Okay, and that's the first part. Now moving on to part 2. Now, second question. We're being asked to discuss some statements. 1, the boiling point of the group 18 is significantly lower than the boiling point of group 1 elements with the next higher atomic number. So that what that means is neon is significantly lower than sodium, which is just one more. We need to discuss that. And secondly, a thing I pointed out earlier, the difference between the melting point and the boiling point is much larger in the group 1 elements than it is in the group 18. So we need to discuss that difference. So the first point to talk about is, as we go from group 18 to group 1, where we just get one extra proton being added, an electron, obviously this isn't a huge increase in mass, which with temporary dipole bonding is a factor, but it wouldn't account for such a huge increase. So there must be something else going on there. There must be some other kind of strong bond. And that's where we relate this to the electron C model that's being talked about. But you've got to stress some of the basic points, how bonding is reflected in the boiling point. So the high boiling point of a melting point of the group 1 elements is reflected in strong bonds, and that's kind of one of those key points. Now if we get back to the electron C model, so that's next. So when we look at the model, we have this electron C model where cations are surrounded by a sea of electrons. There's electrostatic attraction. This is a very strong attraction. It's a metal bond, and it takes a lot of energy to break this bond. Now, key difference between this and group 18 is that they don't have any charged particles. We have that slight an instantaneous dipole that happens, but these are fully charged species here with the metal cations or atoms surrounded by the electrons. So it's a much stronger attraction, therefore it results in a much stronger bond. And we can talk about the states of these as well. I mean, they are called the noble gases, and that reflected in the fact that they have weak So in group 18 they exist as gases, and in group 1 they exist as solids because of that much stronger bond. And anyway, that's that point covered there. And just make sure you give a complete answer in terms of descriptions of what's happening with bonding. Now, one thing we haven't covered is why is there a significant difference between melting point and boiling point in the metals. As we recall, in group 18 there's very little difference in this case, and in the case of metals, boiling means you've got to overcome all of the attraction that occurs between the different ions. So obviously in melting we're just disrupting the lattice a little bit, so we're breaking some of these bonds, but to all intents and purposes there's still quite an attraction going on in there. So it means having to break the bonds completely between each metal cation and the electron, and that requires a large amount of energy to do so. So we're not completely disrupting it when we melt it, but we are when we boil it, and that counts for the difference in metals. And in gases, though, well, they're fairly weak bonds there to start with, so going from melting to boiling, there's not much difference because of the weakness of the bonds there to start with. Okay, and that's part 2.